Hello and welcome. In this video, we are going to talk about how to differentiate using the quotient rule and the derivatives of the four trig functions that we have not yet talked about. So let's start with the quotient rule. In the last video, we talked about the product rule and how basically what we did if we had the product of two functions that we were taking the derivative of was we took the derivative of one times the other and added it times the original function times the derivative of the second. And the numerator of the quotient rule actually looks a whole lot like that, except that we are subtracting instead of adding, because typically properties that relate to multiplication associate with addition and properties that relate to division associate with subtraction. So notice the numerator here is exactly the same as the product rule, except we are subtracting because this is the quotient rule. And the only other difference then is that the denominator exists, which it didn't in the product rule. We are going to divide that derivative by the original g function or the original denominator function squared. So let's practice using this property. I'm going to call the top function here my numerator. I'm going to call that my blue function, and the denominator is going to be my red function. So to find f prime of x, I need to take the derivative of the top. Well, the derivative of 3x squared is 6x, and I'm going to multiply that by the original denominator minus the numerator, 3x squared minus 2, times the derivative of the denominator, which is just going to be 2. That whole thing is going to be over 2x plus 3 quantity squared. And I'm going to clean this up a little bit. You do not need to expand the denominator. You can leave it as 2x plus 3 quantity squared. In certain cases, it's going to help you to simplify the numerator, and what I mean by that is to multiply both of these things out and combine like terms. But for the purposes of you getting used to how to use the quotient rule, I'm just going to leave it 6x times 2x plus 3 minus 2 times 3x squared minus 2, and make sure that your fraction covers the entire numerator. The other new thing we're bringing in this video is that we have talked about how the derivative of sine is cosine and how the derivative of cosine is negative sine, but what we haven't talked about are the derivatives of tangent, secant, cosecant, and cotangent. So the derivative of tangent, f prime of x in this case, the derivative of tangent is secant squared of x. The derivative of secant is secant x tangent x. The derivative of cosecant is negative cosecant x cotangent x. And the derivative of cotangent of x is negative cosecant squared of x. Now these you need to memorize. Whether you're using Quizlet or some sort of other flashcards, you need to know these four and the original sine and cosine derivatives. But let's focus in the rest of this video on how do we use those derivatives, and specifically how do we use them with the quotient rule. Okay, looking at number 1, I can see my numerator function is x squared. My denominator function is cosine of x. So when I take the derivative of the numerator is 2x times the denominator, cosine of x, minus the original numerator, x squared, times the derivative of the denominator, negative sine x, or you could change this to be plus x squared sine of x. And that whole thing is going to be over cosine of x quantity squared. And I'm going to leave it just like that. For number 2, I'm going to go ahead and rewrite my numerator using rational exponents. So this is going to be x to the power of 2/3 over x cubed minus 1. So identify your two functions. The derivative of the blue function is going to be 2/3 times x to the power of negative 1/3. That gets multiplied by our denominator function minus the original numerator times the derivative of the denominator, which is going to be 3x squared. And that entire thing is over the denominator, x cubed minus 1 quantity squared. Now, number 3 should look familiar. It should look like a problem that we did in the product rule video, and we talked about how we could change this to be a product by saying sine of x times x to the power of negative 1/2. What we're going to do in this video is we're going to keep it as a quotient. So this is going to be x to the power of 1/2, so that we can identify our numerator function and our denominator function and find the derivative now using the quotient rule. So the derivative of sine is cosine of x, and we're going to multiply that, cosine of x. We're going to multiply that by the denominator, which I'm going to actually put in front, x to the power of 1/2, minus, keep your numerator the same and take the derivative of the denominator, which is 1/2 x to the negative 1/2, and that's all over x to the power of 1/2 squared. And let's clean this up just a little bit. This is going to be x to the 1/2 cosine of x minus 1/2 x to the negative 1/2 times sine of x, all over. When we have power to power like this, we multiply, so that's just going to give us x. Number 4 is going to have a couple of things going on. We have product rule, no quotient rule, since there's no quotients here, but we're now going to be using two of the four new trig derivatives that we just learned today. So I'm going to treat these as two separate pieces. And I need to make sure that I'm using theta and not x, since this video or this equation is in terms of theta. So the derivative of 5 theta is just 5 times secant of theta. So I'm using the product rule on the blue part here, plus 5 theta times the derivative of secant, which is secant theta tangent theta. Now I'm going to do the product rule on the green function. So the derivative of theta is just 1 times tangent of theta, plus theta times the derivative of tangent, which is secant squared theta. I'm not going to combine any like terms. I'm just going to leave this exactly like this. And then we're going to move on to our last two examples. So to wrap up, we're going to extend this back to the whole idea that we've been talking about since the very first unit, which is finding the slope so that we can write the equation of a tangent line. So here we're going to find the tangent line that passes through each function, and to write the equation of a line, we need to know a point and a slope. So again, I can start by filling in, if this is my point, I'm going to have y minus 1/3, and I'm going to leave space for my slope, x minus 2. And why don't you go ahead and pause the video and use the quotient rule to find the slope, and then evaluate that slope when x equals 2. And then unpause the video and see how you did. So here's our derivative, and now we're going to evaluate that when x is 2. So when I plug 2 in, this is going to become 1 times 2 plus 1, which is 3. So 3 minus, over here, 2 minus 1 is 1, times 1 is still 1. So 3 minus 1 is 2 over 3 squared, so 2 over 9, and I'm going to fill our slope in with our equation of the line. Number 6 says that we're looking for a horizontal tangent, and what's missing on this problem is there should be a point that we're finding the equation of the line. So I'm going to add a point. We're going to be finding this at the point 1 1/2. So I just am throwing that in there so that we can find the equation of a line passing through a point. So we can already set this up like this, and then we need to know when we have a horizontal tangent, meaning which x value gives our derivative, makes our derivative 0. So go ahead and pause the video and use the quotient rule to find the derivative here. So here's my derivative. I'm going to go ahead and simplify my numerator. So there I have it simplified. I want to know what x value makes this derivative 0, and that's going to be when x equals 0. So my slope is going to be 0. So this line is going to be y minus 1/2 equals 0, or y equals 1/2, which makes sense. It should be a horizontal line since we were looking for a horizontal tangent. Let's go ahead and recap what we learned in this video. We started with identifying what the quotient rule is and how to use it. We identified the 4 trig derivatives that we had not yet found. We completed some practice problems with both the quotient rule and involving some of those new trig derivatives that we identified. And we wrapped up by tying these back to writing the equation of tangent lines. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.